Hello, this is Scholastic Sam with another math and science video. Today we're going to be starting our chemistry unit, learning about chemistry, lesson 1.1, chemistry and subatomic particles. Now, what is chemistry? It's the study of atomic and subatomic particles. This means it's the study of atoms, molecules, the stuff in them, which we will learn about later, known as subatomic particles, and the relation between all of those. Now, the difference between a molecule and atom is just usually a molecule is made up of a reaction between multiple atoms. So a molecule might be like H2O. There might be one molecule of that, but there might be one atom of carbon. And the periodic table has all of the atoms on them. And it is organized by protons as you go up, and the different amount of subatomic particles. Now we're going to look at this now. Now here, if you want to pause and take a look, you can see all of the different rows, columns, elements, and types of elements. Like these. We look at the step right here. I don't know if you guys can see that, but there's a little line going there. And the ones to the left of that, like the ones over here, are non-metals, while the ones over here to the right of it are known as metal, but the ones on it are known as metalloid. Now the rows on the periodic table are known as groups, and the columns are known as periods, and they are organized by the valence electrons. As we look, we see 1, 2, 3, 4, 5, 6, 7, 8. Now it goes 1 through 18, but usually these transition metals in here, you're not going to count those. That's just going to be 1 through 8, which is the amount of electrons on the outer shell, also known as the valence electrons. And as it increases, going down on the periodic table, the number of subatomic particles increases. Now, the subatomic particles, there are 3 subatomic particles. The atoms are the building blocks of everything, and these are the building blocks of atoms. We have the proton, the neutron, and the electron. Start with the first one, the proton. The proton is clustered in the nucleus of the atom, and it is clustered with neutrons. It's positively charged, and its weight is about 1 atomic mass unit. Now, that is the unit used to measure atomic weight, which is very important when dealing with elements and atoms. And this determines the atomic number of an element. For example, hydrogen is atomic number 1. It has 1 proton. If you change the amount of protons, you change the atom, or which element it is. Now, it's clustered in with the neutron, which is clustered in the center with the proton. Its weight is also 1 atomic mass unit, which means that protons and neutrons are what determine the atomic weight. And it has no charge, which just means it's neutral. And we go back, we see that it is positively charged. A proton has a charge of 1+, which will be important later. And an isotope just means it's just a version of an atom with multiple different amounts of neutrons. For example, you can have carbon-14, carbon-13, carbon-12, which we'll explain later. That means carbon can have either 8, 7, or 6 neutrons. Each different one is an isotope. When you change the amount of electrons and protons, you really drastically change it. But this just changes which isotope it is, which also is very important. But it won't really change what you write about it. It won't change which element it is. We go into our final one, last but not least, the electron. The electrons are what's known as the outer shell. They're in rings. The first one is 2, has 2 electrons, and the rest have 8, or depending on how many electrons each atom has. And they are circling around the nucleus in rings. These are usually in the shape of an elliptical. And they have no impactful weight, meaning that only the protons and neutrons affect the atomic weight. And these have a 1- charge, meaning that they're negative. So protons and electrons are what determine the charge. Now, as we saw, when you change the proton, you change the element. When you change the neutron, you change the isotope. And when you change the electron, you change it into an ion. It means it's non-neutral. So the protons do not equal the electrons. Now, a cation has a positive charge, meaning there are more protons than electrons, and an anion has a negative charge, meaning there are more electrons than protons. Now, charge, it can be modeled by C equals P minus E. The charge is the protons minus the electrons. If you have 4 protons minus 3 electrons, the charge is 1 plus. And the AW, which is equals N plus P. That means the atomic weight measured in atomic mass units is the neutrons plus the protons. If an element has 7 protons and 8 neutrons, that means that the atomic weight is going to be 15. Going over here to our first practice problem. Let's go up. Now, this is usually how elements are drawn. It's going to be in the full model. Now, up here, we have 1 plus. That is the charge. That means that there is 1 more proton than electron. Down here is the amount of protons. That is 6, which means that it's carbon, which you can see here, which is the atomic symbol. Every element has an atomic symbol, which is an abbreviation that denotes which element it is. And it has 6 protons, which means the atomic number is going to be 6. And up here, we have the total. We don't have the neutrons. Many people think this is the neutrons or get confused. This is the atomic weight, which means this is the combined number of protons and neutrons. Now let's start figuring these things out. This is all the stuff you need to know about this right here. The name. Then the name is usually the element, carbon, and then the weight, 14. Now, carbon 14, we're not going to get too much into it. It's used for carbon dating, which determines the age of fossils. Now we're going to go to neutrons. Actually, we'll just show everything that's given to us. We have the element is carbon. We go down to protons. You see protons right there is 6 protons, meaning that the atomic number is going to be 6. The weight, as we saw up there, was 14. And the charge was 1 plus. So now we have to figure out the neutrons. Now the neutrons, we know the neutrons plus the protons equals the weight. So 6 plus the amount of neutrons equals 14. We rearrange the equation. We find out that neutrons at 14 minus 6 is 8. And if we have 6 protons and 8 neutrons, that means the atomic weight is 14. And that checks out, meaning there are 8 neutrons. And how many electrons are there? Now we see it's a 1 plus charge. And the charge is protons minus electrons. And we have 6 protons. So 6 protons minus how many electrons is 1? It's going to be 5. 6 minus 5 is 1, meaning there are 5 electrons. Now let's go into practice number 2. We have this one. This, I'm not going to tell you it. You guys should try to figure it out. Maybe pause the video. Okay, well, this is uranium-235. It is used commonly in something that's used to make energy with nuclear fission. Now, the name, as we see, it's the, I'll go by this one a little quicker. It's the element name, which is uranium, followed by the weight, which is 235. So the amount of neutrons is going to be 235 minus 92. Now, so let's say we need a calculator for this. Or we're going to figure it out, which I like to have my calculator up just in case I need to make some quick math, which is important in chemistry because chemistry is a lot of math. 235 minus 92 equals 143, which means that we have 143 neutrons. And this checks out because 143 plus 92, 190, we get 233, add the 2 is 235. Protons, we see there is 92. Atomic number is going to be the same as the amount of protons. It's going to be atomic number 92. And which uranium is atomic number 92. The weight, you see there, is 235. Atomic mass units, that's the atomic weight. the charge is 2 minus. So 2 minus. Meaning that there are 2 more electrons than protons, because the charge on an electron is 1 minus, the charge on a proton is 1 plus. Because electrons are negatively charged and protons are positively charged. And to be clear, if it was the same, if it was a neutral atom, meaning that the amount of protons equals the amount of electrons, there wouldn't be anything written up there. You wouldn't write a 0 or anything. And usually if it's 1 plus, you just write plus, and if it's 1 minus, you just write minus. So in the electrons here, we have 92 protons, and we know it's negative, so 92 minus what is negative 2? 92 minus 94 is negative 2. And yeah, so that is all you need to know about subatomic particles there and all their equations and stuff. So that's it for Scholastic Sam. Please like and subscribe and turn on your post notifications, because we will continue to post very educational videos involving math and science. And if you subscribe, like, and turn on post notifications, you can learn more and you can help this knowledge reach more people. And again, if you have any questions or concerns, you can email me at sammypaulk@icloud.com. Thank you, bye, and remember, knowledge is power.